Next, there are some transformations which are of minor importance, but it's always better to understand how these transformations work. The transformations that we are going to deal now is, so we have the curve y is equal to f of x. You know the graph of y is equal to f of x. How does the graph of y is equal to integer part of x look like? Y is equal to fractional part of x look like? So let us try to understand this roughly. So first, if you have the graph y is equal to f of x, the process to find the graph of y is equal to integer part of x is very simple. What you need to do is, you need to observe the values of y. So make a grid corresponding to the values of, integer values of y. Make a grid. Now use the definition of integer part function. So now let this be x1, let this be x2. So in the graph, in the next graph also, let this be x1 and let this be x2. So the analysis is something like this. As x is in between this x1 and x2, the values of f of x, are in between 0 to 1. The value of f of x is in between 0 to 1. So what happens to the integer part of f of x? If f of x lies between 0 and 1, the value of integer part of f of x will be equal to 0, right? The value of integer part of f of x will be equal to 0. So all these values correspond to each of these values of f of x. Integer part of f of x will become equal to 0. And exactly at this point, f of x is equal to 1. So integer part will be equal to 1 here. So you have a hollow dot and we have a constant function corresponding to y is equal to 0. All this graph will get to its floor. Now at this x1, exactly the value of f of x becomes 1. So integer part of f of x is also 1. Similar thing happens at x2. So the graph jumps now. Now let us go to the next value. Let this be x3. Let this be x4. Now x3, x4. So between x1 and x3, the value of f of x lies between 1 and 2. So what will be the value of integer part of f of x? It will always be equal to. So you have a constant function here. So similar thing happens between x2 and x4. The value of f of x is between 1 and 2. Between 1 and 2. Hence, the value of integer part of f of x will be equal to 1. And exactly at x3, the value of f of x is 2. So the value of integer part of x jumps. And then between x3, x4 and let this value be x5. Between x3 and x5 it remains 2. Between x4 and x6 it remains 2. So this is how the graph moves up. So you just need to find the grid points and you just need to bring all these values of f of x to its floor. So 0 is a floor, 1 is a floor, 2 is a floor, 3 is a floor, so on. So wherever the values lie, you bring all those values onto the floor. So this is how the graph of integer part of f of x looks like. The process is simple. Draw the grids correspond to the integer values. Bring each of the values to their floors. First identify the values of x corresponding to these values. First draw the grid corresponding to the values of y. Find the corresponding x values. And between the x values, depending on the value of f of x, just need to bring the values to their floor. Next, if you want to draw the graph of y is equal to fractional part of x. So fractional part of x is nothing but x minus integer part of x. So fractional part of x is nothing but f of x minus integer part of f of x. So now from x1 to x2, integer part of f of x is 0. Hence, the graph is y is equal to f of x. You have the same graph. You have the same graph. You have the same graph. So here, and between x1 and x3, you have to subtract a 1 from this graph. So that means this graph comes down. This graph comes down uniformly by 1 unit. So this point comes down and again it rises by 1 unit. It rises up here. And then this part comes down by 2 units. So this point also comes down here. This part also comes down by 1 unit. This part comes down by 2 units. So on. This is the graph of y is equal to fractional part of f of x. As you can see, the fractional part of f of x values always lie between 0 and 1. Because fractional part of any number will always lie between 0 and 1. So this is the graph of integer part of f of x. This is the graph of fractional part of f of x. So these graphs just move so that they come between 0 and 1.